In this example, we want to find the currents I sub A, I sub B, I sub C, and I sub D in terms of the voltages V sub X, V sub Y, and V sub Z, and the resistances in the circuit, R1, R2, and R3. Let's do I sub A first. I'm going to use Ohm's law. In order to use Ohm's law, I divide the voltage across the resistor by the resistance to get the current through the resistor. But I need to make sure the voltage and the current that I'm using agree according to the passive sign convention. Since I sub A is positive in this direction, I need my positive voltage terminal to go here. Assumed positive current enters the assumed positive voltage terminal. That makes this the negative voltage terminal. I'll call this voltage V sub A. According to Ohm's law, I sub A is V sub A over R1, and V sub A is the voltage at the positive terminal, V sub X, minus the voltage at the negative terminal, which is V sub Y. Divide that by R1, there's my expression for I sub A. Now let's do I sub B. To use Ohm's law to calculate I sub B, I need the voltage across the resistor, but I need to define it such that positive current, and I sub B is entering the left terminal, enters the positive voltage terminal. So my voltage V sub B is like this. I need the positive terminal to the right, the negative terminal to the left. Assumed positive current is entering the assumed positive voltage terminal. Now I sub B is VB, which is VY minus Vx over R1. The voltage at the positive terminal is Vy, the voltage at the negative terminal is Vx. I divide that by R1. These variables are both defining the current through this resistor. So they have the same numerical value. The only thing that's different between them is the sign convention I'm using. The sign convention is switched because the arrows are in the opposite direction. So I sub B should be the negative of I sub A. If you compare this expression and this expression, that's true. It looks like we're in good shape. Now let's take a look at I sub C. I define a voltage across a resistor R2. I'll call that V sub C. I need to define that such that positive I sub C is entering this positive voltage terminal. So I sub C is equal to V sub C over R2. V sub C is this voltage, the voltage at the positive terminal, Vz, minus this voltage, Vy, which is the voltage at the negative terminal. So IC is Vz minus Vy. That's my voltage difference V sub C divided by R2. Finally, let's find ID. Find ID, I need to define a voltage across the resistor R3, V sub D, such that its positive terminal is the terminal that the assumed positive current is entering. Now, ID is equal to VD, which is Vy minus Vz over the resistance R3. That's all there is to it.